So the immutable lightness of an edge platform. Does anyone get a bell ring with this title, just for curiosity? Anyone?
What's the writer?
Milan Kundera.
Yes.
Okay, so the inspiration obviously is Milan Kundera. He's a philosopher, a writer, and he has nothing to do with edge computing problems, obviously. So it will come back why we chose this title. We have certain challenges at the edge, and we have this contract that we want to build about an edge platform, to address those challenges, right? We want to standardize how we deliver software at the edge, and we want to deliver fast the software, and so on and so forth. These challenges is always the same. How many people actually work with edge computing? Everybody. Okay, so do you all agree with this? So let's put it this way. Who doesn't agree with this? Perfect. So we all agree with these problems. Then we move forward.
Yeah.
Okay, so Milan Kundera, his point, the title of the book, by the way, is The Unbearable Lightness of Being. And the lightness as meant of this detachment, this lightness of taking decision, and the weight of responsibility, the weight of consequence of whatever actions we take. Now, from an engineering perspective, I know it's fun, it's a long shot, but from an engineering perspective, we can look at lightness as we want to move fast, also at the edge. We want to deliver software, want to ship when we need to ship. We want to change what we want to change, or maybe we don't really change. We will see if we change or we replace or we fix or whatever it is. So this is, and then we have the weight. The weight is the stability. The weight the edge has to be stable, has to be reliable. It cannot be highly available. All right, let's see how that goes. So
hello everyone. My name is Mauro Morales. I am a staff engineer at Spectro Cloud. One of the projects we work on, it's Kairos. I'm a maintainer there. You can also visit our booth tomorrow in the project pavilion, and we can talk more about that. But today, there will be enough, I think, Kairos in this presentation. I'm also a co-host in the Cloud Native community in Belgium and part of the Deep Roots community group.
Thank you. My name is William Rizzo. I'm a CNCF ambassador. I'm a Linkerd ambassador. I'm in the Kubernetes release team. I contribute to many other projects, also to Kairos and to Metal Cube and to some things. I'm also sitting in the Deep Roots working group. Please join if you know what it is. If you don't know what it is, come around. I'll tell you. And that's my current face. So, back a second. I shouldn't have shown you that. How many people think that we should? So, one moment. When we upgrade a firmware, okay? How many people upgrade firmwares at the edge? Yeah, right. How many people upgrade microcode at the edge? Actually, it's the same people. Firmware is another name of microcode. Anyway, so we don't really upgrade microcode. We replace it. That's how it works, right? Now, our argument is, why are we upgrading the software then? Why are we okay upgrading the software? If we replace the software that we run on the hardware, directly on the hardware, this microcode, why shouldn't we do the same with the rest of the stack? Right? We replace the hardware, we replace the microcode, we replace the software, we replace the operating system, we just replace. So, how many people do not, I want this obviously to be interactive, so I'm wondering how many people of you do not agree with what you're seeing in the slide now, with this replace rather than fix? It's okay not to agree, yeah? I'm not gonna look for you afterwards. So it looks like we all more or less agree. So we have, in the entire stack, looking at one system or looking at multiple systems, we are sitting on top of the hardware, whatever is sitting on top of the hardware, we should be able to replace it. We should be able to trust it at any stage, even if it's in the most unfavorable condition, meaning somebody can go there and can replace what's running on the hardware. That shouldn't be happening, right?
As William was saying, we do this already for firmware, but we also already do it at a, we could say, kind of high level of the stack with pods and containers, right? Whenever you deploy a new application, a new version of your application, what happens? You don't go into every one of those containers and maintain and upgrade inside the container the components to make it the new app. What do? You kill those containers and you spawn new ones. If someone would come here and suggest, hey, wait a second, why are we killing all those containers? Such a waste. Let's maintain them. What would you say? I personally would think, okay, I think this person really hasn't experienced this pain of what that would mean, because we have many of containers. That's why we have Kubernetes, right?
Yeah. So we are not talking about immutability since what, 2 years, 3 years, or 5 years. We're talking about it since 2012 already. You guys remember those two sentences? Okay, perfect. So it was
very nice audience, by the way.
I love this audience.
When we go in other places, we have to interact more.
As you said, we want to replace anything. So, because all of you remember these two guys, I'm not gonna stand too much over it. But the only thing that I want to say is that Phoenix server is something. It's obviously a metaphor of something that rises from the ashes, right? But that thing should be destroyable. It should be trashable at all time. We should be able to replace declaratively the whole stack, assuming that replacing the hardware is something that straightforward.
Indeed. And the problem is that we still, for some reason, at least at the OS layer, we like mutability. We like this idea of SSHing into a node and upgrading something, and it feels powerful, right? Like just like this T1000, it was like impressive how it could convert into all these other things.
Well, the D1000 was powerful.
Yeah, it was powerful, but in the end, it is problematic to have that skill, because the truth is that, and I tell you this as a story, back in 2015, I was working at a very interesting piece of software which would go and introspect Linux systems. You could go and tell exactly the current state of the system, and the idea is that by doing that, we could help in all the problems where you would have some snowflake. But what happened? The introspection was done too early or too late. It was never done at the time of the breakage, right? Like if we knew when the system is going to break or not going to be configured the way we want it, then we wouldn't need for those kind of solutions. And we do a lot of those kind of solutions. And that's where the epiphany came for me. The system should not be changing. So what we're going to talk about a bit in depth today is immutable OSs. So we already have agreed in the industry that we moved from pets to cattle, right? This idea that instead of having a system administrator directly touching one machine, we're handling a fleet of machines. And now what I'm suggesting is that we go even further from that idea of the cattle into what we think is appliances. These machines that we don't even get to have snowflakes. That's the main idea. Machines that can do AB upgrades. I guess everyone is here used to the term AB upgrades or atomic upgrades. I'm telling you, you guys already know everything.
Yeah, but many didn't raise their hand.
Factory resets, etc., and declarative setups, of course. And within this ecosystem right now in Cloud Native, we have already quite a few players. I already saw some people representing some of those OSs here. That is really very cool, in my opinion. We have big tech representing that. So it's a problem that everyone is experiencing, at least if they are doing edge, in my opinion. And of course, I'm going to talk about the best of all those solutions. And of course, I'm biased because I work on Kairos, right? Kairos is more than an edge OS, it says there. And it's because it has a special feature that I think none of the other OSs can mention. And it's that Kairos converts an existing Linux system into an immutable OS. That means that you can be based on your, let's say that your company requires licensing for Red Hat. You can take your Red Hat and convert it into a Kairos version, immutable version of it. Or maybe you're using an NVIDIA board and you need to run on top of Ubuntu. Well, you can do the same for that image, convert it into an immutable OS. You can choose between K0s and K3s. We also have a very cool feature called autonomous clustering, which you just tell how many control planes you need, and the clusters are going to start talking between each other and are going to decide who ends up being a control plane and who ends up being a worker. It's fully container-based, so no new technology, but what we already have been working on with Kubernetes. We offer trusted boot, again, as many of those other operating systems do. I like to think that we do it very straightforward to the way Leonard Pottering has designed in systemd, which I think it's a very good architecture. And one of the most important things, no vendor lock-in, because again, you can switch between the different OSs, so you're not going to be stuck in one particular stack. We're one of the sandbox projects in the Cloud Native Foundation, so like I said, please come and visit us if you have more questions tomorrow at the Project Pavilion. Now, digging into why we do this kind of thing, how does the immutability in Kairos work? I think it's very similar to a lot of these other OSs, but this is particular to Kairos. It's not that the OS is fully immutable. If it was fully immutable, it would be useless. It would mean that you cannot run anything because you cannot write to the logs or anything like that. What we do is that we have a strictly immutable section. That's where, for example, if you want to install packages, if you do apt install, you're not going to be able to because apt is going to tell you, I'm sorry, I cannot write into a section that is read-only. Then we have another area which we call persistent. This is, for example, because we're having API upgrades, there are some things that you want, like your home directory, to be between the system that you have right now and the new system that you're going to install. You want to keep your home directory intact and accessible between the two. If you need to do a rollback for some reason, again, you want to have access to your home directory. And finally, we have this area which is fully writable, like I was saying, for example, logs. And those, if they get lost, it doesn't matter after an upgrade, of course. If you're investigating the system, you might want to check the logs, of course. And how does Kairos make that work? How does Kairos go from your normal OS into having what I just previously explained of an immutable OS? It starts with declarative way that you already are using, so Docker files and YAML Cloud Init configuration. From that, you initialize the system, and it gives you a container image. But there's something particular in this container image. It already includes the Linux kernel, the init param.fs. So basically, this is a bootable container image, we could say. And then you start converting those, you start bootstrapping them into images that you can boot into a system. Now, the important thing to think here is that before, we used to think that this was costly, because there's some maintenance in having to convert an OS into something that can boot. Now, you can put this into a pipeline, and the idea is that for every commit that you make, you can create those container images. So it has become something cheap, something that you can easily do, thanks to the help of systems like Kairos. So once you've done that, on day one, you want to provision the system. Kairos will be in charge of deciding which areas of the system are going to be immutable. Of course, everything is configurable, but we come with certain defaults that we think are already good enough. And that's also where certain aspects that are quite complex, I would say, to maintain, like trusted boot, are going to be set in place if you have a TPM chip in your machine. And finally, that's where you can start getting all the benefits of the immutability. You can start having those upgrades, which are especially useful if, let's say, that you're flashing certain boards. I'm not going to name names, but some of them are really hard to flash. Huh? But if you're done the system with Kairos, you just flash it once. And then every upgrade is given to you through a normal mechanism that you're already using, like connecting to your container registry. So it makes maintenance a lot easier, rollbacks and factory resets as well.
Thank you, Mauro. So these are some projects in the CNCF like ecosystem and known that help us with immutability at the edge. K0s, Kubernetes on the edge. We know it? Everybody knows K0s? Yes, nice. Lightweight, very powerful Kubernetes distribution. The maintainer is around here. As you said, Kairos supports two distributions at the moment, K3s and K0s, auto-deploying and automatic clustering. Then we have Cluster API. Cluster API can help us with immutability, but needs a little bit of a push, a little bit of help. And there is another project. So there is a problem as well in the landscape, right? When we're talking about bare metal, we don't have metal provisioning systems that understand immutability, that understand TPM, that understand an install. If we know the metal cube, we know that it uses Ironic. Ironic does pretty much a DD of a semi-installed image, a cloud image, right? It writes on the disks. Therefore, if it writes on the disk, it cannot handle the partitioning that he was talking about that he showed just a little bit before with Kairos. So we need to do an install to be able to write that TPM and to write those partitions. That's the first thing that we need to do. Project Beskar, Beskar 7, it's a cluster API infrastructure, so only infrastructure provider, not control plane and not Bootstrap, for bare metal provision, for immutable bare metal provisioning. I've been working on it, and we are looking into it, and we have, of course, looking at collaborators. It's strictly oriented to immutable systems. It's strictly oriented to install, so it's not working on cloud images at the moment. We might look also at raw images or raw images or cloud images for immutable systems. The operating system supported right now is obviously the best one, right? Kairos, Leap Micro, and Flatcar. The idea was to use only Redfish with virtual media. That has been proven very complex. Not very complex to implement, but very problematic because we have the DMTF Redfish API standard. And as every good standard is implemented in a different way by everyone that is implementing it. So to give you an example, so we all know what the Redfish is, the Redfish REST API is, right? Okay, so if you do it. Okay, so on a normal server, you have a board that is called the iLoad, iDRAC, or BMC. The API, the HTTP, the REST API that you can use to talk to that thing is called Redfish, and it's from the DMTF group. Now, it's a very clear standard. It's a very good standard. It's a very well-documented standard. And as I said, everybody implements it the way they want. To give you an example, the endpoints behind that API, between one microcode upgrade and another one, they might change. I have been in situations where I was thinking that I was talking to the virtual media endpoint, but I was actually talking to the HID LED. Therefore, I couldn't mount the ISO from Beskar. So now, that was a very interesting way of telling you that I'm considering dropping Redfish for obvious reason. I have put in the rollback into iPixie and Pixie. Speaking as well with the guys from Tinkerbell. You guys know Tinkerbell? It's amazing. It's an amazing project. Not the book. So they took a spin with that, right? With Tinkerbell, they thought every system is going always to be networked. If that is the case, I can always Pixie boot. And if that is the case, I can always pass a small footprint operating system for which I can boot the next operating system, right? And that's what we're trying to do, what I'm trying to do with Beskar. After talking for, 1 hour in Portugal with this guy, the idea is to create a little Alpine-based operating system that is going to boot up, do the UEFI inspection of the hardware, and KX. KX? No? Kernel exec. So it's going to pass the rest of the boot to another operating system, basically. It's very fast. We can swap operating system on the go without fully booting the hardware, more or less. Allow me to say that. Okay. How is Beskar composed? Beskar is mainly is three controllers. We have the Beskar, so it's respecting the copy contracts, right? Machine, cluster, and node. So the Beskar 7 cluster, it's aligned to the copy cluster. The Beskar 7 machine is a copy machine. The physical host is an entity, is its own CRD, and it's representing the tie between the Redfish endpoint of a server and the Beskar 7 machine. So there are two stages to load up a host, which will be the first is physical, the Redfish endpoint, and then the tie between the machine that I want to represent and the physical host. And eventually putting together all the Beskar 7 machines into a cluster. Now this how it works. Look at this. This guy might go away. These connections might go away between this if we are deciding to go away from Redfish, of course. So the physical host controller might be slightly different. It might be a good. If you are good at designing architecture, it might be a good moment to step in, so you can say, don't do that, or whatever.
The replacing Redfish is a good idea because in terms of how our OEMs are working towards, right? Because they are kind of basing all their console.
Is it possible to have a microphone for the question? I'm sorry.
There's one there.
So before you ask that question, that was pretty much it. The very last slide that I want to show is the merge forward. Throughout the week, there are several activities in several groups. As I said, the deaf and hard of hearing, blind and visually impaired, we are part of the Deep Roots. The Deep Roots, for those that don't know what it is Black, Indigenous, and people of color. We are not there to be activists. We want to build a bigger network. We want to work together, all together, and have a lot of fun. So, questions?
Yeah, sure. Hello. Okay. So my question is about replacing. You mentioned about replacing Redfish API.
Yeah.
So have you consulted with all the OEMs? Is there any kind of agreement you guys are like? Because I know Dell, HP, Lenovo, all those people are heavily invested on Redfish, right?
Absolutely.
So how does that kind of work?
So they are. Thank you for your question. They are absolutely heavily invested in Redfish, and I think that the work that is being done to accelerate NVIDIA adoption, let's put it that way, is going to require even more work. But they're not working on standardizing. They're not working on speaking one language, and that is a problem. Writing an interface for one vendor does not mean that that vendor will be aligned to that contract throughout the life of their hardware or throughout the life of their microcodes. Dell is not particularly good at that. HP is quite good at it. I'm sorry to make names. But this is. I'm not bound to any of those, so I can do it. So Dell is not particularly stable on this. HP is kind of more stable. Lenovo, I've not had the experience. I know Supermicro on the large systems as doing a good job. On the smaller system, not really. So, I mean, I can also leave it. I can leave that Redfish, but the maintainability is quite hard.
Question here.
You have a microphone there.
Hey, can you comment on, with Beskar 7, you mentioned the reason why Metal Cubed and others might not work is because they're just kind of DDing the image and doesn't support the partitioning scheme. is there a notion of kind of memory residency, just like memory resident OS for the immutable parts, and just having your disk support the read-write partitions, or is it actually writing all of that to disk? I'm just trying to get a better understanding.
It's not writing the partitions to disk. It's doing a DD, so it's writing that table that it had that images, the cloud images, and then it's doing an expansion. But maybe you know more.
It can work, like with boards, we do just write to disk, but you still need some event to happen to tell the system, oh, this is kind of like the first boot where you want to certain installation aspects of it to happen, right? So that needs to be there. We put it in Kairos already, but I think where a solution like Beskar will excel is that Metal Cube doesn't know if that system has a TPM chip, for example.
It's more the security of the immutability. The partitioning, I think, is a secondary problem.
Yeah. So it's more of the design, I think, on being able to tell from those systems if they can or not. Yeah.
By the way, if you would like to discuss this with MetaCube maintainers, they are in the room.
I'm sorry?
If you would like to discuss this with MetaCube maintainers.
Oh, absolutely. Yes. I know they're in the room.
Yes.
Hey, guys. Let's fight later on. I know you're going to do that.
Any other questions? There's one question here.
Thanks for the talk. I got a question about the Kairos factory. So I'm working on the application like AI and robotics. And then it's likely that we have to access from the container to the host system. For example, like we have the proprietary sensors and hardware acceleration. The particular use case that we have is a Qualcomm SoC chip. So the question is, can we configure customized like system image using Kairos to deploy the application to the edge?
Yeah, indeed. You can configure it, and that's the nice thing, that you don't have to learn a new way to configure it. You just work with it like if you're working with a container image. Let's say, I don't have experience specific with the board or the hardware that you're working with, but with NVIDIA, what we do, for example, with some of the AGX boards, is that we start from a Ubuntu image, pristine, and then we start installing the firmware that they need in order for their hardware to run properly. From then, like I was saying, Kairos will be in charge of helping you create the image, helping you make it immutable, and then you have this bootable device that, I don't know, it will depend on your hardware. If it has a USB that you can put, flash into a USB and boot, or if you flash directly on an eMMC, that will depend, but the options are there to do it, yes.
Thank you, good to know.
I think
one more question here.
You talked about having immutable upgrades. Have you also explored the partition way of doing it, where you have one partition which is active, which is immutable, but when you do upgrades, you actually have another partition where you do sort of move into that partition where new code gets rolled out, and then you can boot into that system, instead of complete replacement of the image on the host?
Right. That's basically how it works. So you have two partitions, A, B, active, passive, and then when you're doing the upgrade, you're downloading the new image from a container repository. That becomes the transitioning image, we could say, and then if everything went well, that becomes the active. If something is wrong, then you still have your passive system so that you can continue running that machine and it is not broken. If things go really south, there's also a recovery system that you can access. But the idea is pretty much the same. We don't do what RPM-OS3 or AB roots do because we are not interacting with the system itself there. You're producing these images and you're, we're out of time. You can reach out, Spectro Cloud booth is outside, so you can talk to me there, or Project Pavilion tomorrow. Thanks for your time.
Thank you very much.